Hello guys. Berev, namaste, ndiyepi, akwaba, ni hao, tumelang, sanbonani, kuyamor. Anyway, we have a new book, another book here. This one, there's no much information regarding the owners or the owner of this book. I can't really see much. But anyway, we're gonna go deep into it and see what exactly this book has, what information does this book has. Anyway, this is a lovely book. I won't lie to you, it's so nice, it's so simple. Everything it's been simplified. It's nice. As the book is nice, very nice. Anyway, this is the very important thing that you should understand and learn as a technician. Okay, there are things that are called data sheets of components. Let's say you are removing a chip. Even if you do have a schematic, it's fine, and you are removing a chip. You want to or replace it with another chip. It doesn't necessarily mean you have to find exactly the same chip. No, you can use another different chip, another brand. Same chip but different brand. Even the look, even the naming will change, but as long as the data sheet, the pins are exactly the same. I've seen a lot of people struggling looking for that exactly the same chip. No, you can use another chip, another chip. You know, you don't need exactly the same chip. You can use another different brand. Okay. Anyway, what's a data sheet? Data sheet is a technical guide to any electronic component. Yes, they guide you. They give you information. These are freely accessible and generally are in English. They are structured as follows. That is true. When you have a chip that you want to replace, what you do is you read the information on top of the chip. Anything that you find on top of the chip, take your phone and search that number or search that name, and say at the end, say data sheet. They will give you the free information regarding that chip that you are looking for. You'll see how the pins are laid out, the name, the function of the chip. You will understand everything, guys. Please. Okay. Right. Let's go ahead. And you'll even see the pinout. These are pinouts. They'll show you that pin number 11 does this, pin number 1 does this. They will explain everything. They'll explain even the function, the temperature. They'll give you all the information for that specific chip. Okay. And again, the datasheet can be downloaded free of charge from this website. It's called All Datasheet. The other one is this one, Datasheet Catalog. Guys, these are all free websites. You can search for any chip. They will provide you with a PDF. You'll have all the schematic. I mean, they'll give you all the schematic. Guys, they'll give you everything regarding that specific chip. Okay, let's go ahead. Let's say you are looking for this chip. This chip is what? TPS 5 TPS 51225. Another one is TPS 51225B and 5C. Guys, they will provide you with all the information. Okay, the chip will look like this in real life, and on top of the chip there will be a dots, small dots. Here they give you they cycle the dots. That dot means pin number 1, and this dot will align with this dot on the pad, on the motherboard. That's how you align the chip. Make sure all the pins are touching. This is easy. This is easy to do. Anyway, on the chip, for example, CS1, it means chip select 1. And then pin number 2, it says what? It says VFB1. It says voltage feedback 1. Why you have that 1? It's because this chip, I think this chip does two things, if I'm not mistaken. But I will see. It does two things. I think it generates the 5 volts and the 3.3 volts. So one of the power rails would be named as 1 and the other one will be named as 2. So you'll check, you'll see. And let me see if they did specify. No, they didn't. Okay, so it means chip select 1 for what? For voltage number 1. I mean for power rail number 1. This is the VFP1 voltage feedback number 1 for power rail number 1. This chip, since it generates 3.3 and 5 volts, it needs to know if it's doing the correct job. It needs to get right to the feedback after the voltage has been generated. It needs there should be what? A signal, or there should be a pin reporting back to the chip if the chip is generating what? The correct voltage or not. So the chip get the information from where? From FB, from VFB. Sometimes it's gonna be named as FB, meaning feedback 1. VREC 3. This is a voltage regulator 3. Here you should get the 3.3 volts on this pin from voltage regulator 3. You should get what? The 3.3 volts. And again, number 4, we have VFB2. It means voltage feedback number 2. Power number 2, meaning maybe power 2 is gonna be 5 volts. Maybe pin number 1 is gonna be 3.3 volts. You know, when we are talking about 1, we are talking about the 3.3, and when we are talking about 2, we are talking about what? The 5 volts. Chip selects for CS2. Chip selects for power and 2, of which in our case, in our example, we are saying what is 5 volts. And then we continue. Pin number 6, we have what? Enabled. This is on, telling you that the power rail for number 2, it's on. It says EN2 for power rail number 2, it's on. In our example 2, it's 5 volt, meaning you should have this when you are diagnosing this chip, when you are not sure whether the problem is the chip or some other things. But you should have what? This enabled 2, meaning power rail number 2, it's on. P good, this means power good. This is a signal after checking all the power from the power supplies. Then it's gonna give out this signal saying power good. Actually, it's gonna give out this thing actually saying power is all good. Chip can sense everything and say this power is what? It's good. SW, I forgot, but I'm gonna check for you. This is a voltage boost, V boost 2. And then pin number 9, pin number 10, it says drive high 2, which means DRVH2, it means drive high 2. It means this pin number 10 is driving what? The higher MOSFETs. Driving the higher MOSFET where? On power number 2 on 5 volts. It's drive high. Pin number 11 says drive, DRVL2, which means drive low. It means this pin number 11 is driving the lower MOSFETs. Usually this 10 and 11 are going straight to gates on those MOSFETs, high MOSFETs and lower MOSFETs through gates. V in, this is where the chip receives what? The main power by itself. Imagine the chip, even the chip itself, it needs what? It needs the power. This is where the chip will receive what? The power. And then the same thing again. VREC 5, voltage out, drive low 1. Guys, this is simple. I'm just gonna stop it here. This is simple, same thing, same things. Anyway, I don't want you to get bored. I'm just gonna stop here, and then this is the chip. It's gonna look like this in real life, but the same thing, is the same thing I'm showing you above. And all those pins, this way you check, you pop there, you poke there with your multimeter, you check whether enable is on, whether the V in is coming into the chip. If it does, you move on. Guys, it's easy. Anyway, I love you so much. Bye bye, take care.